Okay, so on Friday we talked about how if they give us a trig function and it just says something like sine of 5, when they give us a real number, that's the same thing as them giving us a radian measure for an angle. So sine 5 is the same thing as sine of 5 radians. And then we've talked about our trig functions on the unit circle. If you don't have this written down somewhere, you definitely need to get this written down somewhere. On the unit circle, the radius is how big? Radius is 1. And so that means that there's 4 of my trig functions that actually simplify. If I know I'm looking at a radian value, or I know I'm looking at a point that is on the unit circle, I can simplify down finding those trig functions a little bit. Sine, which is y over r, but if I'm on the unit circle, r would be what? 1. If I'm on the unit circle, the radius is 1. So this would become y over 1, which would simplify down to just what? Y. Now again, I have to be on the unit circle for this to be true. So if my radius isn't 1, if I'm not on the unit circle, I can't simplify it like that. It will always be y over r. If I'm on the unit circle, then it's just the y part of the ordered pair. What about cosine? How's that one going to simplify for me? That would just be x, because it'd be x over 1, which would just be x. If I'm on the unit circle, can I simplify tangent at all? No. Why not? Yeah, the radius isn't part of that. It's the relationship between the y part of the ordered pair over the x part of the ordered pair. Of my 3 reciprocals, which 2 are going to simplify? Yeah, cosecant and secant, right? Cosecant would become what? 1 over y, and secant would become 1 over x. So it's really helpful if I know I'm on the unit circle. And if I'm just given sine of something, unless it has a little degree mark next to it, I'm on the unit circle. So if I know that ordered pair, I have everything I need for my 6 trig values. We are going to put this into practice. Okay. You guys okay if I change to a different screen? Okay. I've got this ordered pair right here. First thing I want to know is what quadrant would this be in? 3rd quadrant. So I'm going to have my point here. At negative 3/5, negative 4/5. Is this on the unit circle? How would I know if it was on the unit circle? Yeah, I want to know if that ordered pair is actually on the unit circle. How would I determine that? What did we say was true about the unit circle? Radius is 1. How do I determine if the radius of this circle right here is 1? I can do a reference triangle, right? if I draw, now when we do our reference triangles, something that I noticed on the quiz, and so I wanted to point out, reference triangles, you always have to connect your point back to the origin. Theta is always right by your origin. So theta is going to be here. Theta is always by the origin, cannot be anywhere else. And then you're going to make a right angle with the x-axis. So we don't know how big this is. How could I find out how big that was? Pythagorean Theorem. So we're going to do a squared plus b squared equals c squared, or the way we use it most often, second semester pre-calculus, is x squared plus y squared, because those are the two legs of my right triangle, equals r squared, my radius, because that's the hypotenuse. So if I'm going to take x and square it, what's the x part of this ordered pair? Negative 3 over 5. What do I get if I square that? 9 over 25. Plus, and then we're going to do y squared. What am I squaring for the y? Negative 4/5. What is negative 4/5 squared? 16 over 25. Can I add these two fractions together? Yep, they have a common denominator. Carrington, you said what? They add to 1 because I'm going to get 25 over 25 equals r squared. So r squared is 1. What's the square root of 1? 1. So if 1 is r squared, is this on my unit circle?
Yes.
Yes. I didn't think so at first. Just looking at the ordered pair, I wasn't sure. But now that I use Pythagorean Theorem, I know it for a fact. So my r value is equal to 1. That means I can do my 6 trigs. Before I write them down, though, who is positive in the third quadrant? Tangent. And its reciprocal cotangent. Everybody else is going to be negative. So what is my sine value? Negative 3/5 or negative 4/5? 4/5. Why? Yes. Y over r. Sine goes with y. Cosine goes with x. Because the x-axis, since we're making a right angle with the x-axis, that's always going to be my adjacent side. X will always be adjacent. Y will always be opposite from theta. So we're going to have negative 4/5. So what is cosine? Yes, this is negative 3/5. Tangent. Tangent is what over what?
Negative 4.
Yeah. Y over x, or sine over cosine. So we're going to have negative 4/5 over negative 3/5. Is there anything that you notice both numerator and denominator? They both have a denominator of 5, right? That means that part's going to cancel out. So what is my tangent then? 4/3. Let's go do our reciprocals. What is the cosecant? Negative 5/4. Because it's the reciprocal of sine. What is secant? Yep, negative 5/3, reciprocal of cosine. What would cotangent be then? 3/4. y over r, x over r, y over x. And then our reciprocals. You guys okay with these so far? Okay. You guys okay if I put up the next example? Okay. What quadrant are we in with this point? Fourth quadrant. This is going to be over here at 7. This is down here at -3. So here's my point P. Very first thing I always need to do when they give me an ordered pair, when they give me a point like this, I want to connect that point back to what part of my picture?
The origin.
Origin. Always connect it back to your origin first. Why do we connect it back to the origin first? Where's theta? Theta is always going to be right at the origin, or right by the origin. So theta is right here, and then we go to our x-axis, because the x-axis is my adjacent side, always. Is this on my unit circle? Does it have a radius of 1? No. How big are those two sides? Way bigger than 1. And the hypotenuse is bigger than that. So I know this can't be on the unit circle. So we're going to have to find our radius here and use that. So I've got x squared plus y squared equals r squared. What are we using for x and for y? 7 and -3. When I square 7, when I square -3, what do I get? 49 plus 9 equals r squared. When I add 49 and 9 together, 58 equals r squared. Then we take the square root of both sides. Can I simplify square root of 58 at all? I know 2 goes into it, right? It's 2 times what? 2 times 29. Yeah, these aren't going to have any pairs in common. The reason I'm checking this, though, on anything that you guys do for me, if it can be simplified, you need to be simplifying it. So if it had just come out to like square root of 8, yeah, that's 2 root 2, and you do need to take that down because you might be able to reduce fractions. Can my radius ever be negative? No. Radius can never be negative. Square root of 58 is equal to r. So now I have all the information I need to do my 6 trig values. Can this just be -3? No. It has to be y over r, because r isn't 1 this time, so I can't just grab the y part of the ordered pair. So I would have -3 over the square root of 58. Can I leave answers like that? No. Rationalize that denominator. So what is my sign? Yep. -3 square root of 58 over 58. I skipped this. We're in quadrant 4. Who's positive over here?
Cosine.
Cosine. And its reciprocal secant. So now, speaking of cosine, what will my cosine value be? Yes, 7 square root of 58 over 58. Rationalize that denominator for me. Thank you, sir. Because it would be 7 over root 58, but then we rationalize our denominators. What is tangent? -3 over 7. When I go to do cosecant, I don't like to look at the rationalized denominator version of it. I want to go back here. Why do I want to go back to before I rationalize the denominator? Yeah, I can just flip it over and the denominator doesn't have a radical in it then. However, I do want to make sure my negative sign is either out in front or up with the top, because conventionally we don't put it with our denominators. Speaking of, on the homeworks that you guys turned in to me, if you put the negative in the denominator, Canvas marked it wrong, but when I went through and checked it, I gave you full points back for that. So if you put your negative with your denominator, I still gave you full points because it is equivalent. But if you got one wrong and you've checked and you're like, I know I just flipped this over, why did it mark it wrong? It's probably because you put your negative with the denominator there. So I would have negative square root of 58 over 3. What would our secant be? Square root of 58 over 7. And last but not least, cotangent. Negative 7/3. How you guys feeling about this? Better than when we first started doing it? Good. All right, let's put up our next example. I want to find the trig values when t is 0. What in the world do they mean by this? Is t a real number? Is 0 a real number? So when they give me a real number like this and they want me to find sine, cosine, tangent, they want me to find sine of 0, cosine of 0, tangent of 0. That's exactly the same thing as asking me to find my 6 trig values when theta is 0 radians. So whenever you just see a number there, they're wanting you to find these values for our unit circle at that radian mark. Where is 0 radians on the unit circle? 0, like right here on the initial side. Do you guys know the ordered pair that goes with that on our unit circle? 1, 0. And since it is a unit circle, what's our radius? 1. Do I have all the information that I need to write my 6 trig values? Yes, I have x, I have y, and I have r. Sine would be what? Sine would be 0. What is cosine? 1. What is tangent? Remember, sine is y, cosine is x, tangent is what? It's going to be 0 over 1, y over x, sine over cosine. Can I reduce that down? No. If I have a whole pie, can I choose to have no pieces of it? Yeah, that would be 0. When is it not possible? When 0 is on the bottom. I can't have one piece of a pie that doesn't exist, but I can choose not to have any pieces of a pie. What would my cosecant be?
Oh, would be undefined
Why?
because 0 would be on the denominator.
Yeah, this would be 1 over y. So 0 would be in my denominator, so this is undefined. What other value here is going to be undefined? Cotangent. Because that would also then become 1 over 0, right? What would secant be? 1. Because it'd be 1 over x, so I have 1 over 1. You guys okay with these so far? Let's try another one. Three pi over 4. Is that on my unit circle? Yes. What quadrant is 3 pi over 4 in? Second quadrant. It's going to bisect the second quadrant, right? So here's 3 pi over 4. We're in quadrant 2. Who's positive in quadrant 2? Sine. Sine and cosecant. What's the ordered pair that goes with 3 pi over 4? Negative what? Yes, negative square root of 2 over 2. And what's the y part of my ordered pair there? Square root of 2 over 2. All of my over 4s, the ordered pairs are going to be identical, root 2 over 2. By the way, all my fractions are all over 2. The denominators are all 2s. Any of your over 4s are going to be root 2 over 2, root 2 over 2. You just have to watch your signs. Who's positive, who's negative in those quadrants. You doing okay, Max? Okay. Do I have everything I need to write my 6 trig values? Yes. What's my sign? Square root of 2 over 2. What's my cosine? Negative square root of 2 over 2. What's my tangent? Tangent is what over what? Sine over cosine, or y over x. Yeah, close. Square root of 2 over 2 over negative square root of 2 over 2. Negative 1, yep. What about cosecant? For my cosecant? Well, I have square root of 2 over 2, so I'd have 2 over square root of 2, right? Flip it over. But then I have to rationalize my denominator. Yeah, so then I'd have 2 square root of 2 over 2, and that does reduce down to just square root of 2. So if that's my cosecant, what's my secant? Negative square root of 2. What about my cotangent? Negative 1. Because I'm just taking my fraction and flipping it over. Or you can think of it as 1 over tangent. Well, if I do 1 over negative 1, that's just negative 1. How are we doing? What questions do we have before we move on?
So in sine, are you dividing?
Sine, if you're on the unit circle, is just the y part of the ordered pair. It's going to be y over r always. Since we're on the unit circle, it's just going to be y. Hey, Pedro, hun, put that away, please.
Because R is 1.
Yes. So if r is 1, I'm going to take whatever the y part of my ordered pair is and put it over 1. So it's just going to be the y part of my ordered pair.
But if we put like it's 1 over, that is this.
It'd be 1 over square root of 2 over 2, multiplied by the reciprocal, so you get 2 over square root of 2. But then we have to rationalize our denominators. All right. You guys okay if I put up another example? Or do we have more questions on this one before we scoot on? All right. Negative pi over 6. What quadrant is negative pi over 6 in? Which one? Fourth quadrant. Because if it's a negative angle, we're going which way? Clockwise or counterclockwise? Clockwise. If it's a negative angle, we went clockwise. So it's going to be right down here. So here's negative pi over 6. What would that ordered pair be? Square root of 3 over 2 and negative 1/2. And who's positive in quadrant 4? Cosine. So cosine and secant are positive down here. What is sine of negative pi over 6? Negative 1/2. What is cosine of negative pi over 6? Yep, square root of 3 over 2. So what's tangent? Yeah, we'd have negative 1/2 over square root of 3 over 2. So I've got those denominators that are going to cancel, but that still leaves me with a radical in my denominator. So when I rationalize the denominator, what do I get?
Negative 1.
Negative 1 square root of 3 over 3. So far, so good? Remember, tangent is y over x. Sine over cosine. What would my cosecant be?
2 round root 3 over 3.
You did secant.
Oh.
That's okay. Let's write that down.
2.
Yeah.
Negative
Negative 2. And you were right, it's going to be 2 radical 3 over 3 here for my secant. What will my cotangent be? Negative square root of 3. Because cotangent is x over y, cosine over sine. So I would have square root of 3 over 2 over negative 1/2. So negative square root of 3. Does it get easier with more practice as we go through them and we see what we're looking for. I like them on the unit circle because I can just grab pieces of my ordered pairs for the first two. Since the denominators are always going to be 2 if I'm on my unit circle. If there's a denominator, it's always going to be 2. So I can just look at my numerators for sine and cosine. So far, so good? All right, let's do another one. Is this on my unit circle? Where is it at? Bottom, right here. What did you say the ordered pair was? 0, -1. So what's my sign? -1. What's my cosine? 0. What's my tangent? Undefined. -1/0, so undefined. Which of my reciprocals will be undefined? Secant. Secant will be undefined because I'm going to have 1/0. What will cosecant be? -1. And cotangent? 0. Because I'm going to have x over y, so 0 over -1. That's why that one reduces down to 0. Doing okay? Let's do one more like this, and then we'll move on to kind of the last thing that we need to cover in here. You guys all right with that? Okay. Let's look at this one. Is this even on my unit circle? Do something for me real quick. Instead of an improper fraction, what would this be as a mixed number? 6 and 1/3. Is pi/3 on my unit circle? Yes. 6 pi would be 6 times all the way around? 3 times all, 3 full rotations, right? Because a full rotation is 2 pi, 3 full rotations. So if I do 3 full rotations, and then I go to pi/3, that's the exact same thing as 19 pi/3, right? So this is coterminal with pi/3. Where's pi/3? In the first quadrant. Is it going to be closer to the x-axis or closer to the y-axis? Closer to the y. My over 6s are close to the x-axis. My over 3s are close to the y-axis. So we're going to be right here. This is 19 pi/3, which is coterminal with pi/3. What is this ordered pair? Square root of 3/2, yes. All your over 6s and over 3s are going to have these two values. It's going to have a 1/2 and a root 3/2. You just have to decide which way it goes. Which one's bigger? 1/2 or root 3/2? Root 3/2 is bigger because root 3 is bigger than 1. Since it's closer to the y-axis, the y value is the bigger one. If it's closer to the x-axis, then the x value would be the root 3/2 because that would be the bigger one. Does that make sense? Okay. Let's write down our 6 trig values here. What is my sine? Root 3 over 2. Ooh, I forgot to ask my question. Who's negative here?
Nobody.
Nobody. Everybody's positive. What is my cosine? 1/2. What is my tangent? Square root of 3. What is my cosecant? 2 square root of 3 over 3. Take sine, flip it, and rationalize. What is my secant? 2. And my cotangent? Square root of 3 over 3. Okay. We're going to keep practicing these guys, but this idea of XYR, XYR, XYR is going to keep coming up over and over and over and over and over. Somebody asked me in 4th period, and I loved this question, is it wrong to still think of it as opposite, adjacent, and hypotenuse? No, it's not wrong at all. But we're going to talk about it in terms of X, Y, and R for 2 different reasons. One, mathematicians are lazy, and X, Y, and R are faster to write than opposite, adjacent, and hypotenuse. Second reason, though, is that, not right now, but later this week, we're going to learn how to graph these functions. Because I can keep going around this circle, around and around and around and around and around. These sine, cosine, and tangent values are just going to keep repeating themselves as I move around this unit circle. I'm going to show you guys what these look like real quick. So I've got sine and cosine on the left, tangent on the right. You don't need to write this down right now. Like I said, we'll actually get to graphing these later. If you look just at the sine and the cosine, we're moving around the unit circle. On the top, it's graphing our cosine, the x parts of the ordered pairs. And the x parts of the ordered pairs keep bouncing back and forth between +1 and -1. +1 is the highest, -1 is the lowest. And it makes this wave pattern. Sine does the exact same thing. It bounces back and forth between +1 and -1. What do you notice when you see sine and cosine being graphed at the same time? They're off. It's like the same exact pattern, but they're just a little bit off from each other. What do you notice about tangent? Does he look anything like sine and cosine? No. No, he looks very different. So it starts off by increasing forever, but then it like stops, and then we jump down and we're at like -infinity, and then it comes up and it increases. It almost looks like it has what? It almost looks like a cubic. Except it's like repeating, right? And it kind of has these cutoffs that remind me of vertical asymptotes. Kind of holding that middle one in between, repeating on the left, repeating on the right. Why do you think it has vertical asymptotes? What did we see happen with our tangent function sometimes?
It will be undefined.
It would be undefined. If my cosine value, my x value is 0, that's my denominator. That's an undefined, so it's going to give me an asymptote there. So anytime my cosine value is 0, up here, down here, we're going to get these asymptotes. I want you guys to write this down. These are our formulas for negatives. If I have a negative angle, that means I'm counting clockwise. So what this tells me is, if I go clockwise to an angle, and I want the sine of that angle, it's the same exact thing as if I went counterclockwise, and then I just stuck a negative on the beginning of it. cosine, it's exactly the same as if I went, like, if I go counterclockwise, if I go clockwise, it's the same either way. And then tangent, we have the same relationship as we do with sine. I want you guys to think about those quadrants for a minute. What's the acronym I gave you again? All students take calculus. Where is sine positive? First two, 1 and 2. If I have an angle here by going counterclockwise, if I go the same way counterclockwise, the y part is negative. Same absolute value, positive if I go this way, negative if I go this way. If I rotate clockwise all the way around here, or sorry, counterclockwise, positive. If I go that same distance the other way, negative. That's why it has that relationship. Cosine. That's my x's, right? It's positive in 1 and 4. If I rotate counterclockwise, it's positive. If I rotate clockwise, it's still positive. If I go more than halfway around the top, my cosine's negative. If I go the same distance around the bottom, it's still a negative. So my cosine's not going to change no matter which way I'm going. But sine and tangent will. Right? One last thing I want you guys to jot down. Because of this relationship right here, cosine is an even function. That means it has y-axis symmetry. Sine and tangent are odd. That does not mean x-axis symmetry, but it does mean what? It's the other kind of symmetry we have. Origin. Odd goes with origin, O's. All right. Couple things quickly. I'm going to pass back your quizzes. You cannot keep them. Put them in the cardboard tray when you are done looking at them before you leave the room. Your 6-3 homework is due tomorrow night. We've got about 5 minutes worth of material yet to cover in 6-3, and then we are done with that. We will start 6-4 tomorrow after we finish this up. If you guys have any questions about this, please let me know. And remember, I need these back before you leave. Pop them in the cardboard basket before you head out the door. Thank you guys so much.